Okay, so we'll look into this question, and the first one is a good example, so we'll see how we can proceed with it. But let me create some space. Okay, so all right guys, so the question says a thief spotted by a policeman from a distance of 400 meters. When the policeman starts chasing, the thief starts running. If the speed of the thief is 10 kilometers per hour and that of the policeman is 15 kilometers per hour, how far the thief would have run when he is overtaken? So this is a simple example, but let's see. I will try to solve it by two methods. The first one, of course, is the usual method of relative speeds, and the second one is, of course, using that of proportionality. Okay, so the relative speed concept is pretty simple. I have a gap of 400. There is a policeman, there is a thief. Thief is running at the speed of 10 kilometers per hour, and this fellow is running at 15 kilometers per hour. Now the very first thing that comes into my mind is that both the speeds are given in kilometers per hour, whereas the distance between them is given is 400 meters. So let me just quickly convert this thing into kilometers. So I'll just write it 0.4 kilometers. So by the concept of relative speed, time to meet will be 0.4 upon the difference. So the difference is, and also remember that they're running in the same direction. So they're running in east direction, west, whatever the direction is, that is the same, right? So if this is 5 kilometers per hour, multiplying this by 5 by 18, converting it to meter per second, right? So now I can eliminate this much. I hope that is visible. So this becomes meter per second, which becomes 0.4 into 18 by 25 into 10. So if I just leave it over there, and if I do not calculate, or rather if I do not simplify this, and I do not really need to, cut this thing into bits and pieces. So what I will say is, because both the thief and the policeman, they're running simultaneously in same time, I could just multiply, because this is the time, I'll multiply the speed of the thief. So speed of the thief is given as 10 kilometers per hour, again multiplying that by 5 by 18, which will leave me something like this. So when time gets multiplied by the speed, I know what I am getting. I'm getting the distance. Okay, so this is the distance. This is the distance that the thief will cover after started running. Okay, so let me try to do this thing. So 10 and 10 cancel out each other. 5 5s are 25. 18 and 18 cancels each out. So this is 4 by 5 kilometers. If I multiply this by 100, rather 1000, I can get 800 meters. Okay, or in other words, if you just do 1 by 5 is 0.2, so 4 by 5 is 0.8. okay, so 0.8 kilometers is as good as 800 meters. So this is the first approach. Let's look into the another approach. Okay guys, so the another approach is also something called as the approach by proportionalities. Okay, so there's a distance of 400 meters between the policeman and the thief, and the moment the thief starts running, policeman starts chasing. So effectively what I am trying to come at is time is constant. Okay, time is constant, and if time is constant, I know speed will be directly proportional to the distance. Okay, So speed of the policeman by speed of the thief, 15 upon 10, which is 5 threes are 5 twos are 3 is to 2. Now 3 is to 2, if this is distance of the policeman also and distance of the thief also. Now pay attention. Can you straight away put dt is equal to 100, I mean 400